Okay, so there's a handout going around. There was an opening in the schedule, so I decided I would fill it and talk about, well, follow up on something that I talked about last year around this time, but also something that relates to work that the previous speaker has done, although he didn't talk about it. But Robin Hanson has done work on prediction markets, and he's part of a project, as I understand it right now, to organize or to develop some kind of prediction market infrastructure for the replication crisis. And I'm going to talk about my understanding of his approach and something that I would suggest as an alternative approach. So just a few key ideas figure into this. Last year when I talked about this, I was talking about the last year when I talked about the replication crisis, I was talking about this suggestion to lower the p-value cutoff from 0.05 to 0.005. Okay, and I was talking about how that is unlikely to make much of a difference. But one of the reasons, or at least one of the things I talked about at that time was something called Goodhart's law from economics, which is that when a measure becomes a target, then it ceases to be a good measure. And in this case, I think the replication crisis, or at least the use of p-values, is a good example of that, where in theory, the p-value is thought of as it's supposed to give us some measure of the amount of evidence that the data provides either for or against a certain hypothesis, but in practice, the way it's being used is as some kind of cutoff to determine whether papers get published or rejected. And so instead of serving as a measure of evidence, it's actually a target that the researchers, that the scientists try to hit in order to get their work published. And so I guess one way to put this in the context of today's talk is that this p-value, which is computed via probability, so it's somehow related to probability and can be described, or at least thought, can be described theoretically in terms of some kind of type 1 error rate or type 1 error probability, apparently doesn't attain the meaning that this theoretical probability, it doesn't attain its theoretical meaning in practice somehow. And so in this seminar, we talk a lot about Cournot's principle, and I'm not going to talk about that really much today, but to the extent that it relates to what I'm talking about here, what Cournot's principle is, at least quoting from a paper from Glenn, is that the way that probabilities gain their empirical meaning is by taking events of small probability and by predicting that they're not going to happen. And so, as I understand it, this focus on events of extremely high or extremely low probability is what allows us to give empirical meaning to probabilities, and I'm not sure what Cournot or anyone else had to say much about intermediate probabilities. Anything in particular, Glenn? Or was it? It was just high probabilities, right? As I understand.
Yeah.
Right. So
by Bernoulli's theorem, this principle says that the intermediate probability in repeated trials will be a frequency.
Right. Okay. So I guess how this relates is to, I guess, what I'm calling a fundamental principle of probability. I don't know what else anyone else would call it, but relating to Cournot's principle, it's the idea that if you state any probability, it doesn't have to be a high probability or anything, but in order to give meaning to that probability and credibility to this probability, you need to be willing to accept a bet on the opposite side of that claim for the implied odds that are implied by your probability. Okay, so this is related, at least in principle, to what, or at least this might sound familiar if you're familiar with this idea of radical subjective Bayesian. If there's a difference between the two, I think there is a difference, which is that in the radical subjective Bayesian, these are hypothetical prices of bets, and here I'm suggesting that these have to be actual prices of bets. You actually have to put the money up behind the bet, behind the probability, or else it doesn't actually represent your beliefs. You're not actually standing by your claims. Okay.
Just say more about the difference between hypothetical and actual bets.
The only difference I would say is that in the work that I'm familiar with, I guess Di mostly, but in other subjective Bayesian accounts, it's that we interpret these beliefs as some disposition towards betting,
Right.
without any actual requirement that any bets take place, or even any possibility, or even necessarily that these bets could be kind of determined. You know, these might be events that aren't necessarily determinable. So it's a hypothetical disposition towards betting without a requirement to actually make any bets.
Versus, say, this requirement that you can place the bet.
Yes. Yeah. So what happens? So how this is going to come in? How this would come into play is that the way that people publish results is that they might attach certain probabilities to them. One of them might be, I come up with I draw a conclusion in a paper, and I assess that conclusion by saying the probability of replication. If you tried to repeat this experiment, you would be able to replicate it 85% of the time. Okay. Now that's something I could do right now in principle and publish that claim. But where does that 85%? How does that 85% number get tested? Is it possible to actually determine whether or not that 85% is actually 80%? Is it actually 90%? So in principle, I've calculated according to all this theory, it is a hypothetical disposition towards betting, but it's not actually being backed up by any kind of betting. So it allows me to possibly skew the presentation of this probability in a way that might be misleading towards the reader, and that's at least partially related to this so-called replication crisis that I'm going to talk about.
Right. When people say disposition, I think they have in mind tendency to act in circumstances like this. So hypothetical dispositions would be something like, hypothetical qualifier here would not be redundant in some sense. So if you have disposition to P or to phi, then it doesn't matter whether I can place you in circumstances to phi.
Well, so I don't understand what you mean. So if you actually have that disposition, you're saying that if you are put in that position, you will do it.
If you're already put in this position,
right.
You do it. Yeah.
And so I'm saying, okay, fine, you have to be put into that position in order for me to actually believe you.
So you have to be put into that situation?
Yes. So you're talking like a philosopher, right? That if you are actually put into this, if you actually have this disposition, it means you will actually do what your disposition says that you will do if you were put in the position to do it. Is that what it means?
When it comes to disposition, one is counterfactuals, right? Using counterfactuals to analyze what it means to have dispositions to act on something. But this is just very general issue in philosophy. My point is just that there is no category for hypothetical disposition.
Okay, then fine.
Okay,
fine.
Right. So you agree that there's no difference between this principle and the Bayesian and the betting ratio?
No, there's a huge practical difference. But
okay.
Yeah. Do you want? Are you all right with questions?
No, yeah, we always do it.
Okay, yes, this is my first time here. So I'm actually a psychologist. So what you're calling the fundamental principle of probability is really a fundamental psychological principle, right? It's not really a probability. It's common sense wise. It's are you willing to put your money where your mouth is? That's the whole hypothetical thing is not really. I don't see it as a psychologist. I don't see it as particularly important because the problem is people making shit up, right? That's the problem. And what this is targeting is an attempt to hold people accountable so they don't make shit up as much as they have in the past.
Yes, it is. Glenn, yeah, go.
So
Yeah.
there's some issue of perspective here. If you say the probability on all the evidence everybody has is such and such, then I'm more comfortable with your fundamental principle that, okay, nobody else has any better evidence, so somebody comes along and offers to take this bet, I should be willing to do it. But if I say I'm Di Finetti, you know, you may know more about this than I do, but this is my probability. That's not quite an offer to bet, because you may not want to bet with them because they may have more information. So
Well, then your probability, then you don't really stand by your probability. I mean, in this, so.
this is, I mean, it's hey, that could be. I think maybe that's a weakness of Di Finetti's position, but the emphasis on subjectivity, that it's just my probability on my. I think
This is a purely subjective principle.
I think that's one reason he falls back on this disposition business, is because he realizes other people might have more information. Somehow it's going to be very subjective. It's just based on my information. This is how I would be disposed to act. But only in situations where the counterparties don't have any more information.
Okay, yeah. Well, this will come into play here because, so one is that we have to get away from kind of dispositions to acting, because we're talking about real things. I'm trying to get to a real thing here. And the situation you talk about somebody having more information, the people who are going to be coming up with these probabilities have the most information. They're the people who actually are doing the work. So I don't know if that'll take care of your concern, but
Well,
we can come back to that later if you don't mind.
Well, I mean, I think it's not a concern, it's kind of a context that I would.
Okay, so the context, okay. Yes.
I guess I'm still struggling to see what the substantive difference is between the dispositional versus the non-dispositional kind of talk, because if I cash it out dispositionally and then they don't act along with this supposed disposition, then that's evidence that they don't have that disposition in the first place. So I guess I'm wondering like what the difference is.
Well, why don't we can try to move a couple slides ahead, because the difference is that people claim things that they might actually not act that way, but they're never put in a position to actually do it. So you can't test their claims. And I think that if you talk about a scientific conclusion or a scientific claim, it should be testable. One thing that people do to justify conclusions in science is they put probabilities on them, or they put things derived from probabilities on them. And then when they turn out to not turn out, then the question is, how do you test an 85% probability versus a 75% probability? And so that's one of the goals here. Okay, so one key idea is to actually test these things, and I think you're absolutely right that if they were put in a position to actually back up their claim and they didn't do it, then that's evidence that they didn't actually believe the claim in the first.
So maybe a friendlier way of framing this that would be nice to philosophy people is to just say that you're providing like an empirical way of testing whether or not certain dispositions to, this dispositional account works. Maybe.
Sure. Okay. So it can be thought of in that.
Okay.
It's an empirical. Okay. Good. So here's a paper from this is from 2005. This is a widely cited paper by John Ioannidis on titled "Why Most Published Research Findings Are False," and in there. He has a claim that it can be proven that most claimed research findings are false. So actually, his claim is an example of the title of the paper, because it absolutely cannot be proven that research findings are false. But he does give a good argument that explains why most published research findings are false. And he gives several reasons that I'll come back to in a bit. Studies have lower power than they should. There's a multiple testing problem. There are degrees of freedom in how a researcher presents their results, and there's all kinds of incentives that that make it worthwhile to possibly misrepresent or deceive when presenting scientific results. And it's about these incentives that gets to this idea of empirically testing these claims. So to talk about a replication crisis, there's a first question of, there's this sense that what's in the literature isn't that the literature isn't replicating at the rate that it should be. But the question is, what proportion of results should replicate? And this is just general. This is very generic and basic hypothesis testing calculations. There's to any hypothesis test. So most or many findings that are published are supported by hypothesis testing. Not all. Okay, but this is just an example that given that we're testing a hypothesis, there are two types of errors we can make. We can either wrongly reject a true hypothesis, or we can fail to reject a hypothesis that's false. These are type 1 and type 2 errors. And the false positive rate gives us a measure of what proportion of all findings that are reported, all positive findings that are found using this method are in fact false positives. And this depends on both the type 1 and type 2 error rates, and also on what's called the prior odds. What proportion of tests of hypotheses are we testing are actually false to begin with. And this is related to the replication rate in the sense that we would expect something that is a true positive to be replicable. Okay, so some empirical evidence here is that there have been a few more recent studies to actually try to replicate results in the literature. They found that 39% of findings in one particular study, 37 out of 97 in psychology, were successfully replicated. 61% in experimental economics. Most recently in August, there was a paper reported that replicated 62% of the articles published of some subset of articles published in Science and Nature between 2010 and 2012. So it seems like these are small. These are relatively lower than they should be. Question is whether it actually contradicts theoretical expectations. If you look at the default p-value, or the default cutoff of 0.05 with some standard assumptions about the prior odds and the power, in fact, the false positive rate would be expected to be about 36%. So one argument is that actually this isn't the 60% replication rate seems low, but we're setting up the parameters in such a way that makes it so that we can't expect much better. But I think it's important to realize that when these results are published, they're not just based on a single hypothesis test. They're supposed to be based on more than just running one test one time. There's a scientific theory. There's a rationale behind the argument. So, in principle, this theoretical false positive rate should really be an upper bound, and it should probably be a very loose upper bound on what we should observe. Yeah.
RR stands for replication rate?
Replication. Yeah, replication. It's just 1 minus this. Yeah.
Okay.
And this is under the assumption that anything that's a true positive is replicable, which isn't really true.
Right.
Okay. So the question is, okay, what should we do about this? And I'm going to talk mostly about these last two, but there are other suggestions. One that I talked about last year, the redefined statistical significance, based on this observation here. Well, if you think about it, if we just lower the cutoff to 0.005, then the false positive rate should immediately be reduced to about 5%, so we'd be much better off. There are other arguments in favor of results blind review and pre-registration that I'm not going to talk about. And then I want to talk about the two approaches that seem to be related, but are actually, the more I think about it, are a bit different. Are more and more different the more I think about it. Okay. So just to review this this paper here, redefined statistical significance was published a little over a year ago by 72 authors, one of which is John Ioannidis himself. So there's a lot of well-known people on this paper, and it's more of a well, if you read it and if you know the backstory, it's more of a political document than anything else. In that the authors of this paper really wanted to throw some weight behind the idea that, well, one, I guess their abstract simply says we propose to change the default p-value threshold from 0.05 to 0.005, but a lot of the argument is using Bayesian ideas, and so there's some reason to believe that this is also kind of a push more towards the use of Bayes factor over p-values. And they claim that if we were to make this change, then a lot of good things will happen. There's a number of flaws in the argument that have been pointed out by a number of people, and I've written about that myself. But I'm not going to talk about this here. The key point, the key thing to that I want to highlight with respect to this suggestion and other suggestions, even pre-registration, is that they are proposing to keep us still within the bounds of the current way of doing things. In other words, the way that published claims, or that scientific claims currently get evaluated prior to publication, is by some appeal to expert opinion. So there's referees are going to read an article and they're going to base their decision. In this case, they're going to use, I suppose, a .005 cutoff instead of a .05 cutoff, but there's a lot of other subjective considerations that come into play when these experts assess the credibility of a given finding. Yes?
Could you back up and just explain your title for the paper you cited at the bottom?
The title, yes.
The impact of p-hacking.
So, do you want? I can give you a quick summary of the argument that I gave, which I talked about last year, which is just, if you'd like. So it is it's this. This is the title of their paper. Okay.
So this p-hacking is impacting their paper? I'm just trying to understand that.
It's the way that, so they ignored the fact that there are a lot of things going into this replication crisis. Something called p-hacking is the catch-all for that. So they made a simple argument, which is we have low replicability. Well, if you just look at the theory, well, the theory tells us that if we lower this, but they're ignoring the fact that the theory is not actually, the theory is actually violated currently, and the reason is because of this idea of p-hacking. Okay. So now, I'm going to talk about the an alternative approach, which is involved, which Robin Hanson is involved in, and other people are involved in, which is using prediction markets. So here's an example of an expert opinion, and this is getting away from the replication crisis for a second. This is 538. This is the Nate Silver's blog on the election forecasts. Okay, so if you go there, or this is taken from last night or 2 days ago, and you look at the forecast for the New Jersey Senate race, which will happen in 2 weeks, then this is what you will see. So the according to the models that they use at 538, the Bob Menendez, the Democrat incumbent, has a 90.4% probability of being reelected, and everybody else is 9.6% according to this, according to their models and data and so on. And according to, I guess, conventional wisdom, this site is the best at forecasting elections. Okay. If you go to a prediction market, predicted.com, there's a market that you can actually bet on the outcome of the election, and you can buy either side, yes or no. And there's rules for how it gets, how it works. But basically, what happens is the day after the election, if Menendez is reelected, then every share of yes is worth $1. Every share of no is worth 0. If he doesn't get elected, every share of yes is worth 0, and every share of no is worth $1. So here the price is 78 cents. So that suggests that the market is pricing this probability at 78%, and the offer on the no side is 23. So saying that the probability of not being reelected is 23%. Okay, and these add up to greater than 1 at least because there's some spread in the market. Right? Okay, so there's a discrepancy between what the experts say and what the markets say. And there's a big discrepancy. So there are some transaction fees in predicted, but they're not nearly big enough to make it. If this was the true probability and you believe this probability, then you'd have every reason to go in this market and buy shares of Bob Menendez being reelected. You have a question?
How do they update the odds? Suppose I bet $100 and then Menendez would
Well, it's just a market like the stock market, so it's a bid-ask situation. So all that this means is that currently I can buy yes at 78 cents because there's somebody willing to sell it at 78 cents. And so if I go in, I can go and buy it from that person. And then if I buy all the shares at 78 cents, then there might be somebody willing to sell it at 79 cents or 80 cents. Or, yeah. Okay.
Is there a standard markup on that? Can you, like if somebody had $1 million and they wanted to buy?
Well, there's not. I don't think there's that much money in the market. There is a lot of money in these markets, but you can, if you, in principle, if there was somebody with $1 million on the other side, you would be able to do it. Yeah.
What's the most, what is the market that's biggest now?
Biggest meaning the most action?
Yeah, I mean, some of the ones that were.
Probably these Senate markets right now. I mean these.
No, I mean, some of the, probably.
What do you mean? These prediction markets?
Yeah, some of them that we heard of a few years ago have gone out of business. So I was just wondering what the market you're talking about here, which market is it?
This is what Predicted, the website.
Oh, you gave its name.
Predicted.com.
Predicted.com.
That's the only one I know of. Although there may be I'm sure there's others and there's some blockchain ones, but I don't know the extent to which they're actually very active. Okay.
So one feature of this then is I'm losing my vocabulary. These things don't seem to be lasting very long. The ones that were around 4 years ago are gone. The prediction markets.
Yeah, I don't know.
Are they legitimate? I mean, are they regulated like the stock market? I mean, when you say buy shares, the whole purpose for buying the shares is an investment that sometime in the future it's gonna appreciate. If you win, I mean, if the stock market was that easy, everybody would be, betting the kitchen sink on it.
Well, the question is whether this indicates a mispricing or whether which of these is wrong. I mean, we don't know which of these is wrong. That's the question.
So then who regulates that? The statistician? Is that regulated? I mean, it seems to me like that's just, a crap game, a numbers game.
Is the price is regulated?
No, that industry.
I don't actually know. I don't actually know if
One
it's...
of the earliest one of these was the Iowa electronic market, which was around already 15, 20 years ago, and they got some exemption from federal regulations on the grounds that they were research, and they did limit the size of bet you could make.
Yeah.
This is also associated to a research group in Canada, some university.
But then
So
some of the
this
others,
is not like
some of the others have gone.
O2B, they basically went the ways of the dinosaurs, but years ago, there used to be off-track betting.
Yeah.
And that was very highly regulated, because it was a form of gambling. This is kind of like a form of gambling.
I agree, but I don't know if it's regulated. And
So then is it legal, is my question? In New Jersey, for example.
honestly, I don't know if it's legal. I mean, I have money on there, but I don't know.
There's gonna be some guy somewhere in the basement or, the Kremlin or something.
Anything's possible, but so far it hasn't been exposed as a scam.
This one hasn't,
This one hasn't. No.
but others have. I mean, I know something about, I am not up to date, but I do know something about the history of these.
Yeah.
And some of them were exposed to scams and went out of business. And others are located in other countries because they aren't legal in the U.S.
Sure.
So there is a contested history. The current situation, I can't answer the question.
Obviously, this is based on just regular polling. You take a poll, and depending on how independent it is, you can make the assertion that there's a 78% chance.
So it doesn't matter. I mean, unless I'm missing something, it doesn't matter whether this is legal or not, as far as I'm concerned.
Oh, okay.
It matters what these probabilities tell us. Okay. So the most obvious question is which of these is more accurate? Some expert has been crunching all these numbers, or the markets where people are actually putting money up. And what you would say is that, well, if the 538 estimate is right, then there's a 12% advantage, so you should be in this market. And you would think that maybe Nate Silver doesn't necessarily have an incentive to be in the market. He's that's one of the problems with his site, but also that he has plenty of money doing other things. But the people who work for him probably don't have, probably could benefit by buying into this markets, but they're not, apparently. So either the markets are very inefficient or the 538 estimates might be a little bit unreliable. It's possible that both, right? And so the question is, okay, how could this be used scientific? How could this be used in the scientific question, this replication crisis? And this actually was done for this study that was published in August for these 21 studies that they tried to replicate in Science and Nature, and they only replicated 13 of the 21. And they actually did a survey and a prediction market for this. And these were the, should we turn the light off, or can you see this? Basically, there's dark, and there's light. And so you can look down here is the market probability, the market price of probability of replication, and these are each of the 21 papers. So this was so here what we see is that yellow were papers that did not replicate, and blue did replicate. So there actually is a separation here in that the market. So the market are the diamonds. So the market actually separated. I guess, well, I hesitate to say correctly separated into replicate and non-replicate, but it was monotone in the sense that everything that didn't replicate was given a lower probability by the market than everything that did. Yes?
And the market, that happened before the replication process began?
Yes. Yeah. As far as I understand. I mean, I actually don't know how this was administered. Lee, were you involved in this?
I was not really involved with it, but from the paper and there's been conversation about it, there were predictions about replication. They were not, the replication studies hadn't been conducted when people made the prediction, the bets, these are bets basically.
Yeah. So this is just saying that, well, they opened up these markets and people went on them and said, oh yeah, I think this paper will replicate, I think it won't, and then that created
I'm just curious because these are papers that have spanned 5 years, and then assume if they're biological or psychological, it could take time, or even, it would be hard to imagine that we had this market predict. You first open a market and have people bet, and then later on wait for all of them to predict, so that there's a temporal.
No. The market is after those papers on the left were published.
Yes, but were they before the replication process began?
Yes.
So they were able to wait for all of them. So they were able to wait for all of them to either replicate or fail to replicate.
Yeah, that's right.
So that's part of this whole project, which is that they're trying to replicate things in mass to try to get a sense for how reliable these things are.
And these are similar to the predicted outcome, like literal money on the line, or like a hypothetical?
Real money. So the part of them were real money, were real markets, and then others were surveys. So sometimes, so actually you can see the survey, and the survey wasn't actually that different than the market. So you might ask whether it's necessary to have the market in this case. But do you want to say something?
The survey and the market were all at the same point in time for all these papers.
I don't know the specifics of that. Yeah. But I'm guessing that they were around the same time. Yeah. Okay. So this gets to, so this is a real life, I guess, application of a paper that Robin Hansen wrote in the early 90s, I think, which was called "Could Gambling Save Science? Encouraging an Honest Consensus." And the idea here is that is to use prediction markets to get a more accurate measure of the scientific community's assessment of a results, like probability of replication. So it's not trying to assess necessarily. What it's actually measuring here is by having people bet one side or the other. What we're getting is a more honest and a more accurate measure of what people actually think about the publication. Okay. So just because something has a high it's not necessarily the case that just because something has a high probability in this market that it will replicate. It's just that that is the most accurate that is the most accurate measure we can get as far as what people think is going to happen. And the idea being that by putting people into these markets, they're incentivized to actually bet on their true beliefs, instead of when they review a paper, they might have many competing reasons to accept or reject, even if they don't like the paper, or they do like the paper, or they like the people who published it, or don't like the people who wrote it, and this or that.
Can you show that graph again?
Yeah.
Just got it.
So that's a very subjective, non-scientific graph. It's opinionated, it's not based on true statistical experimentation or anything like that. You ask someone their personal view after having read, and in many cases, they probably did not read the paper, but just maybe they scanned it and they thought, yes, is you know, right.
This is like if I went to the internet right now and I read to you the price of Google stock. It's as scientific or non-scientific as that. I don't know what that. I don't understand that question. But you know, if I read to you the price of the stock, that is what this is, and this is just telling you the price that the market gave for that. Yeah. So there's no analysis for. There's nothing really to read into this. It's just This is actually just what it was. You know, if I tell you that the price of a
It's subjective though. I mean, that's.
These are subjective, yes. This is subjective, yes.
Yeah.
In that sense, okay, yeah.
Yeah.
Right?
Yeah, but you can think of it as so often in discussions about science, you'll hear people refer to scientific consensus.
Right.
Yeah.
And no one, what is that? It's either a survey or there's
Right.
like 30 articles on
Somebody
it.
did
Or,
something
but
to-
this is,
It's just-
consensus with skin in the game.
Right.
That's what this is. This is a consensus that you're willing to bet your money on, not just spewing hot air about.
But the survey was nearly as good.
Yeah,
Now, see, the danger of this type of procedure is, if you remember Enron or Cisco, right, many years ago, where people just thought that, oh, it's a hot stock, and there was no fundamental basis to value the stock, or where Enron would say, yes, we have all these investments all over the world, it's just a piece of paper. And then when people went back and checked, then Enron, of course, bottomed out, and people lost billions of dollars, right? And so I don't know if this is really taking us off track or anything like that, but I'm just trying to get some kind of rationale for. How
okay,
is this
well,
relevant?
so the extent to which there's intrinsic value behind these stock pieces of stock is given by this, what's a conditional bet on replication. So these are supposed to indicate the probability of replication, and what it is, I guess, so this is how this would be implemented more broadly, which is, well, you have to get a journal involved first. Submit a paper to a journal, and when I submit my paper to a journal, a betting market opens up. So in my paper, I've written, this is the method I used, and this is the criteria for replication. Say, so let's say I write that into the paper, and then the betting market opens up and says, well, supposing that there is an attempt to replicate this paper, what is the claim results will replicate, yes or no, and you can buy the yes or the no. And so if there is a replication attempt and it's successful, then then this is a yes or a no answer, and the yes will be worth $1, no will be worth 1. If the replication attempt is unsuccessful, yes is worth 0. If there's no replication attempt within some period of time, then all bets are off, and everybody just takes their money back. Okay. So that might partially answer your question, although I think that you would, and I think I would also be possibly concerned about this issue of, you know, what if when I bet I know that there's not going to be a replication attempt, then I could have every reason to kind of manipulate the price up or down. And so, though I can't predict that there will or there won't be for sure, I can pretty much price that into my behavior as well. But the idea here is that whether or not this gets replicated or not isn't the main concern of this approach. The idea is that as was mentioned, to encourage an honest consensus. So we talk about consensus, but we want that consensus to be honest and that it reflects true beliefs of the community. And what the journal can do is it's going to make its decision of where to publish the paper based on, it's going to consult this market price when making this decision. It doesn't have to accept or reject if it's above a certain price or not, but it can consult that price. And if the paper gets accepted, this price will be published, on the first page of the article or something to give some indication of the scientific opinion of that article at the time that it was published. So that's the idea. Okay? Yeah.
What do you think is a good price to put in there for every bet? What's the wager, ideally?
What do you mean, for this yes and no?
Is it just $1? I would think that it would be very different if you say it's $1 or $1,000.
No, but I can buy 1,000 shares.
But would that just tilt the opinion towards whoever is richer in the academic world?
Oh, it could do a lot of those things, and I guess the question, but I guess the argument that Robin Hanson would give, and I think there's merit to this argument too, which is, if you're rich and you just want to inflate the price to make your paper look good, and I look at your price and I think it's out of whack, then then I have every reason to come in and try to take the other side, and so there's going to be money on both sides, and the smart money is going to. The idea is that these markets are made efficient by smart money regulating the price.
But the point being exactly that the utility of money is different for everybody. That it might actually be nothing for somebody rich to bet even $1 million on something, but it would make everybody else, it would become an impossible attempt for everybody else to be able to even, counteract that.
Well, I guess that is a question of how much money, how much liquidity would actually be in these markets, and that's not something that I think we know until
I think
it's done.
I guess my point is that I think it would be impossible to talk about attaching our own betting odds to our credences without talking about the utility associated with the money, or attach because ultimately it's a blind of both my subjective judgment probability-wise and also the good that I'm willing to invest into games like this.
And we can assume, for example, utility is linear dollars.
Bounded from above or no?
Maybe not.
But that becomes a problem though.
Why?
I think there's problems with this approach, but I don't understand that issue. Whatever your utility for money is your business. I don't care. I mean I suppose that what you're saying is that someone could come and manipulate these prices, and somebody who is who's arguing on the free market side would say yes, they will, and I hope they do, because the more people try to manipulate markets, the more people are going to flood into those markets. The more smart money is going to flood into those markets because they'll see a discrepancy to capitalize on.
That would be assuming perfect liquidity of the market and everybody
Sure.
actually having all eyes on these things the whole time.
It would assume some level of liquidity and people paying attention to the market. Yeah. Obviously, for these things to work at all, you need people to actually be in them. You need there to be money floating around. Yes. But the argument I think that an economist would give is that by having people like you're suggesting in the market, that will incentivize even more people to get into the market because it'll create more of an opportunity.
But you might have very few ultra-wealthy people interested in this.
Yeah.
And some of the ultra-wealthy ones might have papers they want to publish.
Yeah, no, there's some, why don't we get this one?
Yeah, can you talk more about the replicators maybe looking into the market and manipulating the replications to match their own bets maybe?
Yeah, so I think that for the sake of trying to get the idea across all these, there's a lot of kind of practical issues with this, and how are we going to validate, valid replication attempts? Those are all things that I think have to be thought about. But I guess the question is, assuming that could be figured out, what would this give us? I think that one simple approach to that is there is at least Now there is infrastructure in place for doing these so-called pre-registered replications. So you could say that the only replications that count are ones that are pre-registered with journal X, Y, and Z. There's ways to, I think, take care of that aren't actually that hard to do. But there are there's all things you could say. Well, what about the replicators cheating and this and that?
Yeah.
But we have that happening now. But I guess.
So are you now going to shoot this down?
I'm not gonna. I'm going to make some observations. So I mentioned before Ioannidis's paper, and he stated a bunch of reasons for low replicability, and I guess for low replicability in the published literature. And I guess we can ask, well, to what extent would these markets address these issues of low power, multiple testing, researcher degrees of freedom? To some extent, I think it would probably address them to some extent, but for one, there is going to be some limitation in researcher degrees of freedom by the fact that the authors have to specify the replication criteria ahead of time. Of course, what goes on prior to publication is still up for grabs, and that might not be reported and probably won't be, because there's still a huge information asymmetry between the authors and the market. Just like there is now, there still will be. And that ties in with the incentives and how these prices are being used. If the price, I guess, like people have been saying, if the price is being used, if high prices are making my paper more likely to get published, I have every incentive to, well, I could try to pump up the price on my own, using my own money, but I risk losing money in that case. Now you could say, well, how much is it worth to me? I might be willing to pay a certain amount of money to get the paper published. But I could have the paper artificially inflated without risking any of my money by doing the things that people already do right now. P-hacking, selective reporting, this and that. Any information asymmetry that currently exists to give authors an advantage over reviewers and journals when they submit a paper would be even more pronounced here. And so I think there's a bit of an issue there. And I guess this is just a play on something that Ioannidis said, is that claim research findings might just be an accurate measure of the prevailing bias in a given field. And I think that similarly high market prices will just be a more accurate, very accurate measure of the prevailing bias in a given field. Just because something that has a high probability according to the market doesn't mean it'll replicate. Just because something has a low probability according to the market doesn't mean it won't replicate. But it is going to be, I do agree that it is an accurate measure of what the community, it's most likely going to be an accurate measure of what people think.
Could you go back to the previous slide? The previous one?
This?
Yeah. Conditional on, if no replication, there's no action.
Yeah, so the idea behind that is that we want to be able to get the information out of these markets without forcing people to actually have to go through replicating every single paper, because the rate at which papers get replicated or attempted to replicate is very low now, and there's very little incentive for people to replicate papers. But if you're making a bet that might actually take effect if there's a replication attempt, you still have the incentive to bet your true beliefs, bet your actual beliefs in that situation.
So what is the purpose? I mean, so this scheme is designed to achieve the journal's purpose, I suppose.
Well, if the journal's purpose is to publish things that the scientific community believes will be replicated, then this will help them achieve that aim better, because we will be getting a more accurate measure of the consensus with respect to that particular measure. But journals have other motives for publishing papers, not just that.
This one seems to be, If you ask people, is this what a journal should this be a journal's goal? Most people would say no, I think. Is that right? Most
I
academics.
think opinion varies now. I think a lot of people are behind this replication idea these days, but
No,
So-
that's
so-
not what you said. You said that the purpose of the journal is to publish articles that the community already believes. I've added a word, but that's kind of what you're saying.
you know, let's suppose we value replication. Okay, let's suppose
No,
that.
but it's about people believing it will replicate, not that it will replicate. This is not.
Right, but I guess this is the best we can do in terms of guessing as to whether it'll replicate or not. That's where that next comes in. Yeah, why don't you?
Yeah. So some of what this is addressing is a long and bad tradition in psychology of if it's published, it's treated as a fact. It's been like that for a very long time, most of my career. I mean, I got my PhD in 1987, and it has been like that for a very long time. Anyone who was at all critical and paying attention knew that wasn't true 30 years ago. But if you said that 30 years ago, you were an insulting cynic and a bully. The replication crisis has made clear that just because something's published, it is not an established fact. Like maybe the result of the study may be an established fact in some way, like the result was obtained, but God knows what they had to do to attain it. And so for new discoveries in new areas, and we're not talking about whether the Earth is round or the center of the universe, we're talking frontier-like stuff, a study or two comes with massive uncertainty. It doesn't establish a fact. And so what this kind of scheme aims to do is to assess the subjective confidence in the finding among the field pending 30 replications establishing what is and is not the fact here. And 30 replications are going to take 20 years. And so to the extent that this is successful, and so a lot of discussion has highlighted, well, there are real practical issues and whether the system can be gamed in certain ways. The goal is to probably reduce, or one effect would be to reduce I would say, the arrogance with which psychologists present their findings as if they're established facts prior to that large body of research actually establishing it. I'll stop there.
Yeah.
So just clarification on the procedure. So the authors say 67 cents for yes. So
No, the author might not have anything to do with this.
Oh, the author.
This is just a market that somebody is offering to sell a share of yes for 67 cents. Someone is offering to sell a share of no or to buy a share of no for 33 cents.
Oh, okay.
So there's
That's the example of
yeah, this is just an example. Okay. Okay, so this is just a lot of things that people have said, so I won't focus on it.
Is this also, I'm sorry to go back one more time. There's no one back to the other one. There's no action if there's no replication attempt. Can we also assume there's no action if the paper is not published by that journal?
I don't know. I mean,
Yeah, I think the problem is we're trying to relate this to like markets that, traditional markets that we understand. And it doesn't make sense. And I think you basically hinted.
Yeah.
This is, I think what I gathered from your explanation is it really is sort of like setting a benchmark for professionals in the field. If you think that your publication is so great, how much replicability is it in your publications based on the statistical analysis? That is what I'm gathering from that. It's not outside of the realm of this genre so if it's a biological study, then maybe the biologists are going to this is going to be important for them. So if 100 biologists looked at it and someone priced it accordingly, then one might say, okay, well, this is probably valid. We might attempt to replicate it. Or if it's in statistics, then they might look at it in kind and say, okay, well, this might be something relevant. I think the price will probably go up if the person is a Nobel Prize winner. and that had published the work, and someone might even price it higher because that person has already been world-renowned in their particular field, and so their publication might be worth a little bit more according to that particular market. The way I understand, I mean.
Yeah, and the idea,
Yeah.
yeah, I think the idea is that all of these things are somehow being taken into consideration by the public or the, you know, the people who are in this market, and there's the price. And that's kind of, all of that information is somehow being figured in there. Not in any precise way, but it
I
is
think,
in that price.
I mean, I don't know how much you're trying to sell this is, I don't know how practical you're trying to be.
It's certainly not a fair market, though.
Okay.
But one practical problem is that people would have their money tied up for a long time.
Well, the stock market.
Well, yeah, if you wanted to stay until the end, definitely.
No, to find out whether the bet, because it's conditional.
Yeah, you have to wait till, you know, maybe a year or
So
whatever.
both parties have to.
Yeah, unless I can jump out early, you know, I can sell off. You know, if they're assuming that there's enough liquidity, I can sell off, just like you can in any
Not
market.
conditional, you sell for what? Because money is not changing hands.
You could, why not? It's a market, I mean.
No, but it's a conditional market.
So,
You are committing.
the money is, yeah, so you're committing the money, but I can decommit my money, right? If I say, oh, I've committed this dollar to yes, and then you come to me tomorrow and you say, I want to buy it off you, I could say, okay. And then,
So now it's your commitment.
yeah. But,
But what did I get paid for that? Nothing. No, I don't get that. How do you sell a
You get paid
conditional
the
bet?
difference from.
you take
the
place,
contract.
so I have a 67 cents in escrow somewhere.
Yeah,
You come around and you say,
my 67 cents.
and you say, well, I say, well, I want, you know, yes, I sell it to you, you put yours in my place and I take mine back, or you actually just give it to me and you give.
Yeah, so the 67 is a good example, right? So let's say Harry has his share at 67, and you think, oh, he doesn't know what he's talking about. This thing is massively replicable. It's a bargain at 70 cents, right? Because I think it's got a 95% chance of replicating. So and he's paid 67. At 70, he'll sell it to you, and now you're good. And if you're right, you're going to end up making $1 off your 70 cents.
So now you have market competition.
Yeah, that's the idea. Yeah.
Oh,
Yeah, that's
Yeah.
Now, again, my caution is, you can only sell this to people who are psychologists, psychiatrists, and people who are in the field. If you approach Bill Gates and Bill Gates wanted to spend $1 billion, obviously Bill Gates is a very learned person, and he would see some kind of value in that. He would say, okay, is this,
No,
can you?
see, this is a great empirical question. Whether lay people, self-selected lay people, or maybe intelligent experts not in the field, do as well or worse or better than experts? This is a tremendous empirical question. I would love to know the answer to that. Just from interactions with intelligent people outside of the field, I am not so sure their guesstimates as to what's replicable and not would be much worse than a trained psychologist. Maybe that's an empirical question. I wouldn't be stunned if psychologists were better, but I wouldn't be stunned if they weren't.
Right. And I see this as an important study, something that you can approach a Bill Gates with, to say, listen, the title was, Could Gambling Save Science? Right? And so a person that really investing in science, a Bill Gates that has $40 billion foundation, might be interested in knowing, okay, well, can you replicate this study?
Well,
I'm willing to give you $50 million to do it.
Well, there's some money going in behind this infrastructure right now, but I want to talk about a second possibility to compare to this.
Only
okay?
because a colleague over there keeps going back to it.
Yeah, well, now I think, okay, so we've highlighted some potential issues and some potential benefits of this possibly, but okay, so but going back to this this initial principle that here in this prediction market, the markets are setting the probability, and that probability reflects the consensus of a bunch of people with regard to what they think the chance of replication is. What this suggests here is that who has the most information at the time? Who has the most information about a study? It's not the people. It's not the market. It's the person who wrote the paper. is there a way to get them to give the most accurate assessment of the probability of replication? So there's a lot of information asymmetry in this in these studies. There's multiple testing. There's every analysis you did and you only reported these couple. That's still going to be hidden from the market in these prediction markets. And it's not practical to necessarily report all of these analyses and to log everything that you've done. It's just not, people don't even remember what they've done. You do so many things, right? But is there a way to actually somehow make it so that regardless of whether you remember it or whether you've documented it, that it's actually factored into the probability somehow? So the idea is that to actually, at the time you publish a paper, like in the previous example, you state the criteria with which it would be considered to be replicated, which might be something like run this experiment, run some protocol for some sample size, compute a certain statistic. If the statistic is bigger than some critical value, we will declare this a successful replication. That's a very clear thing. Otherwise, it's not successful. State the probability that such a procedure is successful, and state the amount of money that you're willing to expose to support this claim. Okay. And in putting this amount of exposure up, you're somehow representing the confidence you have in your claims, or whereas now, you might say that the current way of doing things is within this paradigm in some way, although you don't even state a replication probability in most cases. You don't even state a replication criteria in most cases, although you could. But in the current way of doing things, this exposure is always just implicitly zero. There's no risk there's no monetary risk for making a false claim. But during some say 2-year period, anybody who reads my paper can put up some amount of money, and they would gain the appropriate multiple of that money in the event that a replication fails. Go ahead.
I'm so sorry to interrupt again, but what would happen like if the same two studies that have the same sample size and the test statistic as a measure of replication, but they get different findings? So they both fulfill the criteria for being a replication attempt?
Oh, okay. So the idea. So one thing about this is that we actually have to agree on which replication.
So pick one study.
So we might have to we have to agree on a lot of things, including who's going to actually do the replication.
Yeah.
And so that somehow would be let's say administered by somebody or some neutral party, but we would have to agree that okay, we trust this lab. Whatever they come up with, that's what we're going to go with. So it's a decidable thing. Now, someone else might come up and say, well, I don't want to do that lab, we'll do this other one, and I might say do that too. So you do have two studies, and there could be two different outcomes. You would win one and lose the other. And so whatever the results of these replication attempts, and however much money is won and lost, can be added as an addendum to this original article, just to keep a track of what happens. But the main point is that these papers is that the author here is actually facing directly facing loss for mispricing or misrepresenting his probabilities, and also with this system, I see no reason why there should be any need to reject it or accept or reject anything. Just publish everything. There's money to support the publication. Everything that is a failed replication is still published, and we have a record of it. You have no incentive to publish things that are wrong. So right now, I guess, since papers have some prestige for getting published, I have an incentive to publish something that won't replicate. If I can get it into Science, I mean, I have a science paper, and I might get a second science paper if I can write about why it didn't replicate. So here, if we're publishing everything anyway, there's no benefit to publishing anything because any idiot can publish anything. And the real prestige or the real benefit is when you actually publish something that's correct, and maybe people challenge you on it, and you might actually make some money on it. Yes.
There are journals now that say that they would publish simple replications and even papers that get so-called scooped, because to eliminate, and I would argue, in fact, without that alone could be a good enough incentive for people to actually do honest research, not even to worry about the money, because ultimately people, it's a way of voicing what they think, and then to be able to publish replications and failed attempts at experiments.
So that might be enough for people to do honest research, right? But I don't think honest research is enough. I think people who are bad at research should not be doing research. So they should lose the money and they should be put out of business, just like people who run businesses get put out of business. So
From the research account and personal account.
so it would be nice if it was a personal account, but I think that this could be done, kind of like research accounts, which is that I have a certain amount of funding, you have a certain amount of funding. You put your funding up against mine, whoever wins gets more funding. So the money moves in the direction of the better, more informed scientists. Okay. So
We're gonna have to put a subjective penalty to that, because no matter what, if you had 10 scientists in a room, maybe 4 might, you could easily have an even split, given the nature of the subjectivity of the person's opinion as to the value of whether or not you can replicate the.
no, that's the key point, which is that these experts' opinions no longer matter. All that matters is my opinion, which is as the author, and your opinion, if you're an expert or not. If you think I'm wrong, you can challenge me on that, and we there's no point in arguing about it. We just run a replication attempt, and whatever that says, you win or I win. So it's like betting on a football game. We can argue before the game.
I
I
don't see
think
how that's gonna put bad scientists out of business.
so. Let's say I run a.
Oh, you mean it's not gonna be?
I run a study, and I think that my power was 90%. So I say the probability that this replicates is 90%.
Okay.
You look at it and you say, that's not, I'm wrong. You think the power is 80%, 70%, whatever. So I'm offering you 9-to-1 odds on something that is going to happen 30% of the time, if you're right. So that's a good bet for you. So I'm going to lose in the long run, you're going to win. Okay. So with respect to Ioannidis's reasons for low replicability, these low power multiple testing, these degrees of freedom, they should be priced in by the author. So they might not be, but that's the idea, which is that there's every reason for them to be priced in by the authors, but the author that doesn't price them in is exposing themselves to loss. And so actually the incentive here is for the author to deflate the probability that they of replication. Just like think about how casinos set their odds. Okay, so if you go into a craps game at the casino, the probability on a one roll bet on 7 is 1 in 6, right? So that was yes. But they offer you 4-to-1 odds. So the odds should be 5-to-1. They offer you 4-to-1, and that's saying that's offering the odds as if your probability of winning that bet were 1 in 5, when in fact it's 1 in 6. Okay, so they're downweighting, which means that they're saying that they're presenting as if their probability of winning, which is the other side, is 4 out of 5, 80%, instead of 5 out of 6, which is 83%. So they're deflating. They're claiming that they have a lower probability than they actually do, and that's the incentive that you would have here as the author. Now, the probabilities that are presented here, it's not that they're true or false. They can be wrong. But they reflect the bias or the misguidedness or the expertise of the authors, and if the authors are wrong, there's an opportunity for others to gain. If the community is wrong, then the authors gain. So I think that aside from incentivizing accurate reporting, we talked about this funding mechanism. It's possibly an organic funding mechanism, and a way of aligning information in some way, that there is always going to be an asymmetry in information between the author and everybody else. But somehow I think this is incentivizing the author to, not necessarily to give all that information away, but to at least give some accurate representation of that information. through this probability. Okay, so we're running low on time. So here's a comparison that I would say to put up the prediction markets versus the second suggestion, which is that I guess at one level I think they're similar in that they're trying to use the idea that if you put money behind your beliefs, then the beliefs are more accurate in some sense. The question, the difference is primarily where does the money come from? Is it coming from just anybody or from the people who have direct ties to the paper, the authors? One, and two, what is the probability actually being used for? And in the case of the prediction market, it's being used to make this decision, this publication decision to assess what the community believes, and in this other one, it's just actually to make it's actually determining the prices of real bets that are going to affect the authors. So what are the types of errors that can be made in this system? If the probability is set too high in a prediction market, that's like a type 1 error. So high probability is going to make it more likely that the paper gets published. The author benefits from that, just like they benefit from type 1 errors currently. If the probability is set too low, then they're going to get rejected. They're going to get penalized by the community's kind of lack of information, lack of knowledge, or their just overall inability to assess the true kind of replicability of the experiment. Whereas in this other system where the authors are tied to it, the author will lose money if they set the probability too high. If they set it too low, it gives a conservative estimate, so it actually understates the significance of their results, but principle being a little bit conservative isn't a bad thing necessarily in science. Okay. Also, I guess one thing that I think is important is that if we talk about work getting suppressed from the scientific literature, is that things will still get suppressed in the prediction market setting, where if you have such an extreme idea that that scientists in the community who are working within the kind of accepted paradigm don't like or don't agree with, then then it's likely that that probability is going to be priced low by the market, and it's going to be unlikely to get accepted for publication for that reason. And so the author isn't benefiting from that; they're actually being penalized. Whereas if I were to put something out there that was considered to be so crazy, and I said it'll replicate 85%, then if you think that it has a 15% chance of replicating, then there's going to be a lot of kind of challenging to there's a lot of people challenging the idea, but in the end, if I'm right, I'm gonna win. Right? So there's kind of an equal footing between the existing paradigm and any challenges to it. Okay. So just, I guess some final remarks. I saw this quote from Feynman, which was about, I'm talking about a specific extra type of integrity that is beyond not lying, but bending over backwards to show that you might be wrong, and that you ought to have when acting as a scientist. But I guess one of the, I guess, key features of this idea is that we can make science more reliable without assuming trust or integrity. I think that's the key idea. We see in the empirical evidence that it's not. You can assume that scientists are being honest, but it's not. But why do we have to assume that? I guess we would like to have a system. We'd like to have a procedure in place that somehow takes care of that for us, and I think that this would actually do that. Okay, but thanks for listening, and we can take more questions. Thanks.
You'll have these PowerPoints on the site, right?
Yeah.
Okay.
Go ahead.
What is the target of research now?
Getting published.
Publication is no longer prestigious, right?
Oh wait, what's now? Currently, today?
For, I mean, if we have implemented this procedure, then what will be the new target of scientific research?
Doing honest research.
I would to be right. I mean,
Or to acquire money.
well, that's also the target today, right? But through different means.
So if you're more likely to be right, more likely you can win money in this market.
If I'm more right than you are, yeah.
But presumably the amounts of money involved here are not going to be comparable to the other income streams of very successful experimental scientists.
Well, maybe they should be, I guess. I mean, so if we're talking about research fund, you know, I'm not. If we're saying, let's say I'm not betting out of my pocket, but I'm betting on my research fund. So they have research funds in the millions, 10 millions, a lot of money, right? So right off the bat, you know, 50 or 30% of that goes to administrative costs at the university. Right? So take that 30% and put that in.
No, if this is through your research fund, Barclay gets a share of it too, what you win.
Yeah, but he doesn't get anything if I lose. So if he's hiring bad people, then he doesn't get the overhead. Everybody's got to be in.
But this would create a different set of evaluation standards for experimental scientists than for theoretical ones.
Yeah, I don't think this would work for math. I mean, not that that's science.
Or even for science that doesn't depend on experimental, even for statistical work that's not experimental.
Yeah, I mean, this is very much tied to this. Well, I haven't thought about that, but I can't think of a way to do this in that case. But this is very tied to this idea of replication that we can actually test.
So your assistant professor in an area that doesn't do experimental research is going to get promoted on the basis of papers they published in 5 or 6 years. But your experimental scientist is going to have to wait to see if they're replicated. We'll have to keep them on for 10 years before we tell them whether they're going to be promoted.
Well, I mean, I don't know how it all affects. I mean, it's possible. Well, I guess it's possible. I don't know. Maybe nothing will change. Maybe you still do all this, but then you still just get letters from people to say how great you are, and then you get tenure based on that. I mean, I haven't thought about that problem, but that's on the side of there's actually a scientific problem here, and then there's all the other bureaucratic problems that are hard to solve.
How many people would you expect to be betting in the market for any given piece of paper?
No, I mean, I can't say what I expect because it's not. I mean, it would depend on whether this was. If this became one of the best or the only ways to actually get money for your own research, then you kind of have to be in that market, right? So.
I can imagine like a very niche subdiscipline not having a lot of people being able to even understand what other papers are about. So you can only see maybe 10 or 20 people betting on a single piece of paper. That'd be I don't think that would show a very good, I don't think that would properly display what the scientific consensus of that paper would be.
So what I'm talking about has nothing to do with scientific consensus.
Okay.
The prediction markets does, so if I publish something and you're the only one who wants to bet with me, then it says nothing about scientific consensus, but at least the fact that you're there and that you're at least forces my hand, and that I have to, it's when I put it up, I know that you might come along. So,
Thanks. So I'm interested in this notion of real probability and getting a more accurate representation of probability. And one obstacle to operationalizing probability in terms of betting, I think, is loss aversion, which is something that really skews our betting behavior. So you can read that as saying that loss aversion implies that our probabilities are irrational, or you can read that as saying that probabilities might be irrational. It's just that betting is a really bad measure of our probabilities. So if this is a kind of a bias that really governs bets in this kind of a market, then it's possible it just introduces another huge source of inaccuracy. And you were claiming that this actually helps increase accuracy. in measuring probabilities. So I'm just kind of worried about this not being taken into account.
So you're worried about loss aversion
Or
primarily?
risk aversion as well.
Yeah.
Some
So-
groups, some academics, like say metaphysicians, turn out to be much more loss averse than neuroscientists. And so we'll get really different publications.
Well, there's two ways to address that, I guess.
Yeah.
One is if you're the one setting the probability and you did your analysis and you calculated the probability to be 90%,
Mhm.
You can report it as 75%. You can report it as 50%. I mean, as loss averse as you are, you can go far enough to where you're actually willing to kind of gamble on a 40% edge if you want to, if it's a 90% probability, would you be willing to say it's 50% and offer somebody 1-to-1 odds? Or are you so loss averse that you're not willing to bet at all on
Possible, yeah.
and if you're that risk averse, I would argue you shouldn't be in the business of using probabilities to assess your work. Because what do they mean? I mean, really, what do your probabilities mean? If you're so scared to kind of stand behind the claim that you won't risk kind of losing anything. And I mean,
so I don't think the probabilities are flat. I think the probabilities are multi-level structures, and there are consciously accessible probabilities or confidences, there are unconscious confidences, and there's a really complicated interplay between the two.
I agree with that.
And so the question is, what does betting measure, which level, and how do we correct for that? And it looks like this method offers no correction for betting.
No correction
For betting, so people, you're taking people's bets to be a reflection of their probabilities, but if probabilities are these complex multi-level structures, then we're not really measuring probabilities, we're just measuring one little tip of the iceberg.
Oh yeah, it's not measuring.
So this is not accurate. This is not helping accuracy.
Well, now the word probability is being used to mean two different things. Right?
Okay.
This is testing a specific thing called probability in this sense. If the probabilities in your sense, which I think are also probabilities, are not being tested here, right? So I'm not going to be accurate in your sense, but I'm going to be accurate against this.
We're interested in the same probability, real probabilities, right? What are real probabilities? And I think this is assuming a kind of a picture of a real probability that's really maybe overly simplistic, and it's not getting at the whole structure.
Well, it's extremely simplistic, but
Yeah.
real. I don't know what you mean by real probability.
Well, it's not just betting behavior, is my point. There's more to probability than our willingness to bet. And accuracy doesn't just therefore depend on betting behavior, but on other things. That's all. But
Okay, that's fine. Then you don't have to call these probabilities. But nevertheless, what I'm saying is, when I say probability, what am I saying? I'm saying this is my claim for how often this thing will replicate. And that is all we're testing here.
okay.
So, I mean, I agree. There's a lot else there's a lot else to it. I guess there's two questions. One is, could you test it? But I guess you would also ask. I would also wonder whether that's actually something we would want to test in this situation. I mean, do we actually care about it? I don't know.
Mhm.
In this particular question,
Mhm.
I'd be interested to hear more about exactly what you're saying. But, yeah.
I guess one worry is that maybe the fundamental principle of probability is not about probability in the sense of, say, subconscious level probabilities. Maybe it is about probabilities you're willing to report and to associate with betting behaviors, and that's the one that you're after.
Yeah, I mean, this is a principle of probability in the sense that as far as I understand, the word probability has been used in a standard way by DeFinetti and Bernoulli and people who worked in probability since the beginning. Now, I agree there's a concept of probability that might lie on top of this so-called mathematical theory of probability, if that's what you're getting at. But if you go to the Stanford interpretation, probably there's 6 of them. One is classical. Okay, one is frequentist, one is subjective, and then there's some other ones, right? But the two most relevant to statistics are frequentist and Bayesian, frequentist and subjective. I think both of those lend themselves well to betting behavior. Frequentism, if something's happening a certain frequency at a time, you should bet on it in accordance with the frequency. Or subjective probability as it's been typically kind of talked about. Otherwise, so I think those two things lend themselves to this.
Yeah, I mean, there are a lot of layers of probabilities. maybe one is conscious level, and the other is not so conscious level in the sense of if there's something about loss aversion and risk aversion, maybe you're not going to report that, but you might still be thinking about that when making decisions or actions, but not necessarily in terms of betting behavior.
Okay, I mean, I guess the short answer to your question is I'm not sure how that would kind of play out, right? But one is, I guess I came up to this picture, which is if this was if you were put in this situation and you were loss averse, I mean, everybody has their limits. I mean, if I thought the probability was actually 80% and you're offering me 78%, I'm probably not going to jump all over that. But you know. So in some way, so this isn't going to necessarily penalize people who are slightly wrong in their assessment of the probabilities. But if you're way off, maybe one person might be too loss averse, but somebody will come in. I mean, I kind of understand what you're saying, but I don't know. I think it might be too philosophical for.
Maybe you're washed out in the end in terms of people's loss aversion functions.
I mean, it could, but I hesitate to just make that kind of claim. It's a bit convenient for me. Yeah.
So on the practical side, the idea that you would completely remove the publication barrier is probably problematic because there's other reasons for not publishing something than thinking it won't replicate. It might be poorly written, the result might be so obvious and trivial and known since the beginning of psychology or so on. So if you put all of those things in, it means that the journal editor is going to realize nobody is going to, publishing in my journal is going to be like publishing on SSRN or Archive.
Yeah, that would be great. Okay, so here's where we get to talk about this, which is there's reasons why papers get rejected other than they don't replicate for the reasons you said. But I'm not sure that there's a good reason necessarily. Let's say I write a poorly written paper. So now in this case I publish it, and now who looks like a fool is me. I mean, I'm the one who decided to publish it, and now it's a terrible paper, and everybody gets to see it's a terrible paper that I wrote. Now, if I write that terrible paper, one second. Now, if I can get that paper into Nature, and it's a terrible paper, I'm happy.
Who's happy?
Me. I wrote a terrible paper, and I got it into Nature. Isn't that a good thing for me?
I'm asking what the editor is going to feel like.
Well, he's the one who accepted it. So, so you're saying, what's the editor going to feel like with what? With accepting everything, or?
Yeah. Why would we want to? What would support the existence of a journal like that?
Oh, I mean, this is getting beyond. I mean, we don't need journals anymore. I mean, let's just. But this is.
I'm reflecting a conversation I had a few days ago with a journal editor.
Yeah.
In which I said that to him.
So you were right 2 days ago.
and yeah. So and he rehearsed his motives, which was he's fighting to get those numbers, those citation numbers, and so people will want to publish in his journal.
It's academia as a prestige-seeking organism rather than as a truth-seeking organism.
Published on God's gift.
That's why, that's the bad paper in Nature brigade. Put me up for P2.
Okay.
So how soon before this thing takes off? Like the new tech? I mean, when should I start saving for it now and putting an investment pool in publishing? Bets?
You never know, but it might be a little while. Might be a little while. But I did say
I
that
mean, it's at the experimental stage now.
these,
I mean, this-
as I understand it, I didn't get to talk to him much, but last week's speaker is involved in trying to get some kind of prediction market thing up and running, actually, and that is funded by some organization. So,
For replications?
yeah.
For this kind of, oh, wow.
Yeah.
that's
So I think they are actually doing the first thing I talked
Right.
about. Yeah, yeah,
Years ago, people thought gopher would go nowhere.
yeah.
Younger kids don't know that.
Yeah,
I don't know what that is.
The internet.
The internet?
Right. Okay. I think so, that's what it is.
Okay. All right. Thanks for coming.